203, right? This is aluminum oxide. Okay, so here we have 3 samples for aluminum oxide. It can be made either transparent, either translucent, or opaque. What does this mean? From looking at here, this is transparent. You can see through, you can see the letters, okay, on the paper. Now this is translucent. You can hardly see the letters, but you do see something underneath. But when you say opaque, you just do not see anything below that material. So exactly the same material, aluminum oxide, it can be made transparent, translucent, and opaque. By what? By providing this material with different level of porosity. Okay, 什么叫 porosity 啊？你们的气孔含量。Okay, if there's no porosity, this is a single crystal. It's very good. You can see it through. If you make this aluminum oxide as a single crystal, the optical transmittance can be very good. It is transparent. Then if you have certain level of porosity, it's kind of a low, okay, not many porosities, then that material can be made as translucent material. Okay, now if you have a lot of porosity, very high porosity level, this is a polycrystal, okay, in these 2 cases. Now your material is totally opaque, you just cannot see through. So by changing the processing, you'll be able to change properties. Okay, so exactly the same material, exactly the same chemical composition, you can make the different properties by changing the processing. Okay. Now, also one thing we need to talk about deterioration and failure. 第一个词什么意思啊？什么叫 deterioration？ 就考过4级的同学。什么是 deterioration？ 韩老师知道吗？也不知道。或者知道也能说好。deterioration 什么意思啊？ It means when you expose a material into a certain environment, or if you use a material for a very long time, the function or the property of the material is going to go bad with time. Okay, this is called deterioration. 那么叫恶化。Okay， 材料随着时间的推移，性能逐渐降低的一个过程。我们的 deterioration. Then what is a failure? You just cannot use that material anymore. It fails. It cannot serve the same function as you expected. So let's look at this. This is a steel. If you put steel material into salt water under certain stress, okay, salt water when you add some salt. Okay, now there will be cracks on the surface of the material. Okay, it's gonna eventually break. So what this figure tells you is if you do some heat treatment to that material, okay, if you do some heat treatment to the material, the speed that the crack is going to grow, it will be totally different. Let's look at this figure. Okay, the y-axis is the crack speed. When you have a little crack, the crack is going to propagate, going to grow. Okay, now this is increasing low. Okay, so when you look at this blue curve, without heat treatment, if you don't do any heat treatment, just put it in salt water under stress, under load, okay? Now this crack speed is going to change like this, so as is, without any heat treatment. If before you put this material into salt water, before that, if you heat them up at 160 degrees Celsius for 1 hour, things will be totally different. Now look at this crack growth speed. It's going to be much slower, which tells us that heat treatment will be a very effective approach, will be a very effective way for slowing down the crack growth speed. Even though you put exactly the same material into the same environment, into the same salt water under exactly the same mode. So this figure tells us heat treatment will provide us with a very beautiful way to slow down the speed of crack growth. Okay. Now, based on this thinking, people is gonna divide materials into different types. Okay. Now, right now let's classify materials according to the way atoms are bound together. Okay. So we divide materials into different categories. Probably you guys already know, okay? So I'm gonna go through this very quickly. We divide materials into 5 or 6 categories, depending on how you want to include the advanced materials here today, okay? So metals, what are metals? Metals, what are metals? Metals are, what? What are metals? What are the features of metal? Why do you say this is not a metal? Why do you say my key is a metal? What are the features of metals? Because what? Metals are, compared to others, relatively strong, right? And metals are ductile. Okay, if you stretch the metal, it's not going to break. But you cannot do the same thing for ceramic materials. Okay, they conduct electricity and heat very well. Okay, and they are shiny, or they are lustrous if polished. In metals, the valence electrons are detached from atoms and spread in an electron sea that glues the ion together. So this is the electronic configuration in metals. That's all you have already learned in your introductory course. And also, this is metals. And the second type of material, that's what we call semiconductors. What is semiconductor? Okay, semiconductor means the conductivity of the material is not as good as metals, but not as bad as polymers and ceramics, right? So we call them semiconductors. In semiconductors, the bonding is covalent. Okay, it doesn't matter if you don't know the word. We will talk about this later, okay? So their electrical property depends strongly on the minute proportions of contaminants, okay? Their electrical conductivity is totally dependent on what kind of a very small amount of impurities you add. For example, if you add, for example, silicon, germanium, gallium arsenide, these are examples of semiconductors. They are primarily used in electronic industries. Okay. Now the third type of material is ceramic. Now what are ceramics? Ceramic. Let's look at it. What are ceramics? Okay. Now ceramic are yearly combinations of metals and semiconductors with oxygen, nitrogen, and carbon. Okay, if you have a metal, for example, aluminum, right? Aluminum oxide is one type of ceramic. Okay, if you have metal, then combined with oxygen, nitrogen, or carbon, then you form the